So now let's look at another example. Convert 56.321 degree to degrees, minutes, seconds. So we first keep the integral part. We just deal with the fractional part. So first we can convert the 0.321 degrees to minutes. So we just multiply this guy by 60 minutes over 1 degree. We know 1 degree is equal to 60 minutes. So actually this is just multiply this number by 1, right? Now we cancel this to units degrees, and then we get 0.321 times 60 minutes, and then this guy is equal to 19.26 minutes. Now for the fractional part of this minute, we can convert this to seconds. So let's continue with this. We move to the next page. So we have the 0.26 minute, and then we multiply this number by 60 seconds over 1 minute. So now you cancel this to minute, and then you have the 0.26 times 60 seconds. Then approximately you get the 50.6 seconds. So finally, so this symbol means therefore 56.321 degrees is equal to 56 degrees. What is the number of the minutes? 19. Right, we have the 19 minutes. So we have the 19 minutes. And then the number for the seconds is the 15.6 seconds. Then in this way, we convert this fractional degrees to degrees, minutes, and seconds. So by now, we have talked about the first way to measure an angle, the degree measure. Now let's look at the second way to measure angle. It's called the radian measure of angles. The radian measures of angles is used more in the math and the scientific field. Okay, actually, later when you learn the calculus, you will see for most of time we just use the radian measure to measure angles in calculus. So now, how to get the radian measure of angle? Let's go to the book. And we just take a unit circle. So this circle with radius equal to 1. Okay. And then we put the circle into a rectangular plane with the center, okay, at the origin of the rectangular plane. Now, the radian measure of an angle in the standard position is the length of the intercepted arc of this angle. So right now, for example, this angle, okay, in the standard position with the vertex at the origin, how to get the radian measure of this angle? You may just measure this arc, this intercepted arc. So the length of this intercepted arc is called the radian measure of this angle. So actually right now, this circle is a unit circle, so the radius is 1 without any dimension, right? It's not the 1 centimeter, 1 inch, or 1 feet, just the 1. Then we know this length of the intercept arc is just a real number, okay? So the radian measure is just a real number without any dimension. So if you have the intercept arc with the length 1, then this angle has the radian 1. Okay, has a radian 1. Now, if the rotation is counterclockwise, then the radian measure is positive. If the rotation is clockwise, then the radian measure is negative. So now you can see the radian measure is just a directed length. So this guy, radian measure is a directed length because it has the side, right? When you rotate the ray clockwise, then you have the negative value. When you rotate the ray counterclockwise, then you have the positive value. And we know the circumference of the unit circle is equal to 2 pi times the radius. That is what, right? So let's get the circumference. Of the unit circle is equal to 2 pi times the radius. But it's a unit circle, so the radius is equal to 1. So this is just equal to 2 pi without any dimension, just a pure real number, right? And we also know the full angle of the unit circle is equal to 360 degrees, right? And this is how we get the 360 degrees, because we just divide a circle into the 360 equal arcs, right? So the full angle of the unit circle is equal to 360 degrees. Now we have the two measures to measure the same angle, the full angle of a unit circle. One is in the degree measure, another one is in the radian measure. Sometimes you may write the RD, rad, for the radian measure. Okay, so this should be the same thing. So that means 2 pi radians is just equal to 360 degrees. And you divide both sides by 2. Then you know pi radian is equal to 180 degrees, just corresponding to the straight angle. The pi corresponding to the street angle. Now we need to do the conversion between the radian